can see me, I'm Emmett, and I'm president of the Kansas City professional chapter of ISE. I want to welcome you all today. We have John Huffman, who will be presenting the topic Industrial Systems Engineers as Enterprise Architects. A fantastic topic. Before we get started, let's just cover a few ground rules, I suppose, for our WebEx here. Ideally, if you have a microphone, we prefer that you keep it muted so that John has the floor and we don't have interruptions. Other than that, everyone, and free to look around at all of your settings here at WebEx. They're along the left side if you cursor over your screen to minimize and maximize or zoom in and zoom out. Bottom, you should have options if you mouse over to mute, stop your video, and also bring up your chat options. So please feel free to look around those options and make sure that those are ideal for the WebEx. And let's get started. So thank you all for joining us. John has been a long time standing representative of IISE, served in many positions over the years to revamp and clean up the Wichita chapter. And I will let him and introduce himself before he jumps into his presentation. So, John, the floor is yours.
Thank you very much, Emmett. And I might say right off the bat, we're going to have a question and answer period toward the end here. I've got a lot of information. I'm going to try to get through this really quick. This is really a Reader's Digest version of all this. But if people have questions as I go through it, feel free. You could jump in, just as long as we don't slow down too much. The other thing, again, if you all don't mind, please mute your microphones because we have this breakup that happens if it thinks other people are talking. So that helps a little bit. But again, if there's something I get to and that you really have a burning question about, just feel free to interrupt me. I'm okay with that. So again, thanks for the introduction, Emmett. I'm John Huffman. I think a lot of you know me, so I'm not going to go into great details about my background and all that. But one of the things I think a lot of you know that um, I've had an interesting career in that although I've got degrees that say industrial engineering on them, I've never been called an industrial engineer. In fact, I've always kind of really thought of myself as a systems engineer, if anything, even though I've never really had that title either. I've had so many different engineering titles over the years. And probably the most interesting title I've had is enterprise architect. Uh, it's something that I am really shocked that a lot of industrial systems engineers don't know about this subject. It is prime for us. I mean, you look at it and I go, that's us. When I look under the hood and I see what enterprise architecture is about, it is about what we do typically as industrial engineers or systems engineers. And that's what. Somebody, hey, we got somebody. Somebody's breaking in online. Can you please mute your microphone? Thank you. All right. Anyway, um, I see this as a big opportunity for industrial systems engineers. This whole field of enterprise architecture. It is fairly new. Not only the major companies tend to have an enterprise architecture function, but again, I am very surprised. So I've been trying to get the word out about this. And the first time I presented this was in 2017 at the IISC annual. The next year, they had me come back and actually do a special session on this. Since then, it's popped up in other presentations that we've had through IISC, either on the IAB, the Industrial Advisory Board, or some of the other areas. So it is starting to pick up steam, but it's still one of those areas where a new engineer coming out of school, they may want to consider the path to go down this path, as a career option. So I wanted to give a little bit background on this, knowing that a lot of people don't even know what it is. I'm going to spend a little bit of time up front talking about what enterprise architecture is all about, and then we'll get into the aspects of why I think industrial systems engineers are just ripe for this profession or for this discipline. So anyway, I always like to start out with a little bit of a definition. We use that phrase enterprise and also architecture and in so many other things in very broad context usually. Enterprise, most of us when we think about our enterprise, we're thinking about our company or the sphere of activity that our company is involved in. But enterprise, if you look up the definition of enterprise, you'll see that the usually listed first is that it's an undertaking, especially one of some scope, complication, and risk. Okay, we don't tend to think about enterprising when we do our things. We tend to think about the in other words, as an activity, but as a thing. The enterprise as a thing, and the interesting thing about enterprise architecture, it's both these things. People will immediately go to the second one, thinking it's about architecting the enterprise. And that is part of it. Okay, but there's a lot more to enterprise architecture as a function than just architecting the enterprise. And a lot of it has to do with how we deal with innovation and disruption. So I'm going to I'm going to show you two slides here that I'm going to spend very little time on. They in themselves are another seminar. This is something, these two slides I have been using them, believe it or not, since the early 90s. Uh, and what they do is, way back when I was doing my dissertation, I was looking at the history of basically engineering disciplines and realized that they all kind of followed the same kind of path. The reason I was doing this, most of the work I did for my dissertation was in software. It was neural nets and things like that, a fairly new engineering discipline. And my question was, where's it going? At the time when I was doing it back in the 80s, it was still kind of an artisan practice, this whole idea of IT. And what we had is we had a lot of accidental software engineers, people who started out their careers being other kinds of engineers who moved over into software engineering just because they were really good at programming. But along the way, they brought practices from their own engineering discipline into software engineering. And I think the ones that made the biggest impact were those who were doing what was basically systems engineering. It made us realize that we had to take a really methodological approach to building software, just like we build anything, basically. So it caused me to step back and say, what is that path that we've gone through and where are we going? And I constructed this into what I would call the industrial systems engineering epics. Okay. We started out with the epic of the Industrial Revolution. We moved into the technology evolution epic and then into the information evolution epic. A lot of us have been around enough that we have had a significant portion of that information evolution, and even some of us were even around when the technology evolution was happening. Showing my age a little bit here, but the interesting thing about this is there's a push and a pull that's been going on for a long, long time. Sometimes it's been technology that has been the impetus for where we've been going. At other times, it's been the needs of industry or socioeconomic events that have caused it. We tend to think of things like World War II and the space race and things like that were real catalysts in us to go out and develop new technology. But then we got into the 80s where suddenly technology was driving things a little bit, where we had the advent of the personal computer, and that really changed the way we did business. We had the advent of the internet in the 90s, and that really changed the way we did business. And we've been going back and forth, and that pendulum's been kind of swinging really quick back and forth, a lot faster back and forth as we've been going along, to the point now where I think we really, at the beginning of somewhere at around 2008, 2009, this digital imperative became very obvious to everybody that there was going to be a lot of re-engineering of our corporations, of our enterprises, if you will, uh, based on the fact that we want to digitize everything. We don't want to be in paper any longer. It started out being paperless, but it's become so much more than that. It's become, how do we streamline our businesses? How do we lean things? How do we build those threads of digitalization through our company, so that we have full life cycle approaches to things, and then standardize the systems that we have around them, and deal with different kinds of data. This all kind of really was the one of the big motivators for this, was this whole idea of big data. That data is suddenly the thing that's going to drive our companies and all that. But there are a lot of other things that happen along the way. Obviously, one of the major things is automation got so much better. We hear about the industrial internet of things and all its promises. And even though most companies really don't even have a strategy yet for that, because it is kind of a moving target right now, we know it's going to happen. Okay, so what do we do? What do we need to do as an enterprise to ready ourselves for future automation? And then the idea of hybrid intelligence. The fact that, we used to think of artificial intelligence, and it was a very what I would call islands of automation activity, where it would pop up in certain places, but it wasn't prevalent throughout everything we do. Now it's becoming the smart factory or the smart service center or something like that. That's the big deal right now. So this idea of taking different kinds of intelligence and working them together, and different ways to deploy those intelligence, that's a major thing that's motivating us to do change right now. And of course, the massively distributed service paradigm. A lot of the reason we're I was thinking about this whole situation we're in with the virus. You know, 10 years ago, we probably would have had it. I can't, I think about 10 years ago, if this had happened, business just stops. The economy just basically stops. But now we are continuing on. I mean, we're doing business, even though we're apart, even though we figured out a way to massively distribute our ability to communicate and to interact with each other through various kinds of services that are out there, electronic services mainly, obviously, that allow us to do that. So we've got all these really neat technology now, but we also have major things that are happening in the industry. Okay, the fact that our markets are becoming more collaborative, the fact that we're becoming very domesticated in our technology. Again, I'm sitting at home addressing people that are spread out all over Kansas right now. I've addressed people spread out all over the world from my basement here. And that's interesting, because I'm one of those people that, shoot, I hardly ever go to the mall anymore. I do most of my shopping online. So we've got this interesting aspect, and our companies are doing the same kind of thing. We're leveraging more and more the ability for real-time decision making, the technology services that allow us to communicate well with each other. That doesn't mean we don't want to do face-to-face stuff, and for the sake of my industry, I hope we continue to do face-to-face stuff, because we do need to get on airplanes and visit each other every now and then. But there is this focus on resiliency right now. How we build our enterprises so that they're more agile. I wouldn't say there's complete agility there, but they're more agile and focused to change. Disruption is obvious, a major key element of all this. I know my company, for instance, is doing some things to help out with the current pandemic. It was an overnight success, basically, at my company. A bunch of smart people got together, and some of those people were at a distance from each other, and they figured out how we could um, reorganize some of our processes and some of our production lines in order to help produce equipment for personal protection. So, and that's a really good. And of course, the major thing here is we're becoming really, truly a global economy. This is an interesting test of that economy. The fact that this has happened, that what's going on right now is happening on a global scale, and the world hasn't shut down. We're continuing to go. So, but we are at a period right now where innovation is starting to outpace industry's ability to adopt it. So that sets the standards for this whole idea of what I call the enterprise epic. We are now in this enterprise epic, okay? And when you think about enterprises, whether it's a service enterprise or a manufacturing enterprise or whatever kind of enterprise, you sports, whatever, okay? You're talking about a massive system. is what you're talking about. A very complex, sometimes highly convoluted system of activity that needs to be coordinated at any given time. And this is really what enterprise architects try to do is they try to take this big picture view of the world and bring it into something that we can make sense of. All right. I call it the systematic fabric of business woven with digital threads. The idea, again, that a lot of this stuff is happening now through some level of automation. Uh, so when you think about it, if the enterprise is a system, then you would think that systems engineers would be the guys who are driving it. And they are. They are. And that's where I had a really some heartburn when enterprise architecture first popped up, but I'll get into that in a second. But let me talk about this universal trend toward the collaborative enterprise. Okay, we are in an era where sometimes it's hard to know if you're talking to a person or a thing. Uh, we basically have done our best to try to merge the physical and the digital worlds the best we can. And that includes people, that includes our businesses, and includes all these things that are out there, all these smart things that are out there, the things that we might call industrial Internet of Things or Industry 4.0 gadgets or whatever else. Okay. We're trying to bring that all together. And in the things, obviously, beside there's IoT, there's industry, there's also the things that have existed all along that might need to be retrofitted in order to work. In people, it's people becoming knowledge workers, basically, that we're all contributing to the corporate knowledge base somehow. One of the things that has concerned a lot of companies is the graying of America. We hear that a lot, that we're a lot of our workforce is getting to retirement age, and we have a lot of expertise that's getting ready to walk out the door. What do we do about that? Is it enough to say, well, okay, we're going to lose that and we'll just have to start over? Sometimes it's worthwhile to just start over. You get a whole different set of skills and a whole different set of technology and all that, and it might be worthwhile to just start over. But in a lot of cases, it's not. In a lot of cases, you want to keep that momentum going. And how do you do that? We set up mentoring programs. We try to leverage technology as best we can to pass things from one generation to the next. But I think what it really comes down to is the fact that most companies really haven't thought about the fact that they have a knowledge base and that everybody is contributing to that knowledge base. And how do we do that? How do we build that into whatever digital methods we might have in order to actually populate, manage, govern that knowledge base? And then obviously the whole thing is, I'm an AI guy, so you're going to hear a lot of AI in this presentation where it's about building things that are brilliant, not just smart, but absolutely brilliant, things that could learn on their own. And so the whole machine learning idea and all that coming into many aspects of our business, not just smart machine equipment that's working on the shop floor, but in everything we do. If you're on a call center, the ability to see certain patterns in telephone calls or in issues that pop up and stuff like that. That's going to be a major thing that I think a lot of our knowledge workers in the future will have a big role in building those things. Now, having said all that, and by the way, I get a lot of my information from Gartner. I got to give them a shout out. Gartner is probably it's a research body mainly for IT, but they have reached out quite a bit for operational technology in the last few years. And I get a lot of my information about enterprise architecture and where it's going from Gartner. So if you look at what Gartner has said, this really started out again with this idea that we need to architect the enterprise and formulate a new concept of doing architecture based around big data. All right. One of the things I've always tell my students, as industrial engineers and systems engineers, we have been very focused up to this time on material, physical things. Um, Sometimes we get into things like energy, the movement of things, the consumption of energy, things like that. Okay. What we haven't been really big on is data. Okay. Those are the three things that can be processed: material, energy, and data. And we really haven't done a whole lot on data. And I think that's what led to enterprise architecture being born. The IT discipline noticed that the rules for systems engineering, even though they could apply to anything, appeared to apply mainly to material things. And they said, our thing is data. We need to have something similar to what systems engineers do for data. And that's where enterprise architecture popped up. It was the idea of applying basically the same principles that we use for almost every systems engineering project that comes along and use it for big data projects. Now, on top of that, we also had this advent of the analytic mindset. That our companies need to be data driven. Well, the truth is, our companies need to be analytically driven. Okay, data could be lousy. Let's just face facts, and a lot of our data is lousy. Okay, and I wouldn't want to run my company on lousy data. But if I have good analyses, even if the data is lousy, at least my analyses usually will recognize the data is not good, and I shouldn't be doing that. Okay, so what we've seen now is this trend toward what I call enterprise operations analysis that really sits is a component of doing enterprise architecture, and now trying to make that smart. And in other words, making it very active in how we actually manage and govern what goes on in our enterprises is the idea that we want to create this space of intelligence. So these things kind of build onto each other. You got big data that led to data sciences, which is bringing back knowledge engineering. Knowledge engineering was there in the 80s and 90s. It kind of went away for a while. We have a new wave of it coming through here now, and that's what we're seeing. More and more of our resources being dedicated to this green phase. So again, this presentation is mainly about this foundational one of enterprise architecture. I have other presentations on these that maybe I could come back and do sometime, but I just want to say something really quick about each one of those. Enterprise intelligence is a life cycle practice. It's about us sharing content and sharing knowledge across whatever digital thread we have. Now, I'm showing you the one that Spirit has. This is what I call an architoon, if you will, or a depiction of how our production life cycle works. And ours is no different than any other manufacturer in the world, really. We have different components for how we do it, and of course, we make a much different product than most other manufacturers do. But it's still the same kind of idea that we do some kind of life cycle management. We have enterprise resource planning, where we do most of our business planning and our logistics, and then we execute. We have manufacturing execution with customer relationship management going on, and the idea that this physical environment should be mimicked in some kind of digital twin so that we can do really good analyses. But the idea is that we want to the outcome of doing all those good analyses is to really distribute knowledge throughout the company so that we could do things like design for manufacturing or design for service or design for whatever else. That we have this feedback loop that we're building in our value chain in order to allow information to get back to the sources where it's really needed to begin with. And then we have the enterprise operations analysis part of this, where we look at the different kinds of analytics that we do as a company, and we try to staff or build functions per those. Most of the analytics we've done up till now have been mainly what I would call metric-based type stuff, the descriptive analytics, and that's really good stuff, But the hard stuff, the stuff that I think really makes an impact let me step back there. That's good for knowing how well you've done. But if you want to know where you need to go, you need to do more of what I would call the forecasting type, the predictive and the prescriptive analytics that you would want to do in order to figure out where you want to go with your products, with your workforce, whatever else you've got going on. And I always put this one in here that's kind of a little bit of a bridge between them, where I think knowledge-based system tends to fall. That it's one of the things that bridges, both our history of doing things. We gain a knowledge, but then that knowledge is also very proactive for where we want to go in the future. And we are constantly revisiting that to build a new knowledge base. Now, any of you who've studied analytics might recognize that this is part of Davenport's model. Davenport, when he first wrote the book on analytics in the workplace, had a 5-step. I think there were 5 of these blocks in there. I've got another one that's more what I would call an ontology for this, that we're actually using that spirit to try to align some of the business functions that we have right now. Because right now everybody does analytics. Everybody should do analytics, but doing this kind of analytics, this really advanced analytics, That requires a bit of talent. And if you're sitting there as ISEs, you should say, wow, I do that stuff. Those are the kind of things I do day in and day out. And that's another reason why I think this is really prime for us. So now let's really launch into this enterprise architecture. I'm not going to read this all to you. I'm just going to read to you some key phrases out of each one of these that bring it all together. It's about using a comprehensive approach at all times to guide organizations through business, information, process, and technology changes and utilizing the aspects of the enterprise. Okay, so you've got some key things here, and really the biggest key thing is it's about bringing business information, process, and technology together, and then put it in under some kind of change control or change management. There are many models out there already for enterprise architecture. It's not like every company has to have a different one. In fact, the more we standardize it, the better it will be. But yet, most companies will take one of those standard packages like the TOGAF model, that's the open groups model, or there's one called the Zachman model, and there's some that the military, U.S. military have put together. There's some that government agencies follow. So people will usually take one of those or parts of many of them and will synthesize their own enterprise architecture. That's pretty much what we did at Spirit. But almost everything, every enterprise architecture you see has this layered approach where one of the layers in it, and then I know this doesn't look like a build-up layer here. Okay, ours looks more embedded, but one of the layers is the application layer, and then you have the data layer, and you have a process layer, and you have an enterprise strategy layer, and you have an infrastructure layer. And the idea is these enterprise architects try to bring this all together. They're they're creating the standards that these work within. They're mapping it to roadmaps for new system development. They're helping with the resource management that needs to go on it. And the main thing is they're trying to integrate the systems that are going to make this all happen. And again, as IISEs, that's what we're about. We're about systems integration, pure and simple. I always say that, you know. It's funny. I always watch these videos where people say, well, industrial engineering, it's about process improvement. I say, which engineering isn't about process improvement? Okay. Every engineering out there is improving a process somewhere if they're doing their job right. Okay. What we're really about is systems integration. We're about bringing all this stuff together and making it work. Taking the things that were built in a disparate manner and making them work together. Sometimes that's through complicated interfaces. Sometimes that's through standard protocols. But there's a whole bunch of different ways of doing it. And that's what industrial systems engineers tend to do. And that's why I think we make the best enterprise architects, because that's the nature of our game. Um, this one happens to be one that's for a company like mine that would do some kind of production, manufacturing production. The applications will likely be different. Not all of them, but ERP and customer resource management, portfolio management, and then general applications would probably be the same for a service industry. They may have a different kind of service lifecycle management. But anyway, this is where the what I say the rubber meets the road here, because again in IT, where most enterprise architecture still is taking place, it is about really managing this and the data. Okay, and when I say data, it's not just the raw data, but it's also the analytics and the business intelligence that go along with the data. On the process side, you have both the processes that face the customer and your internal processes. And then, of course, extremely important is that you have a really good global infrastructure. If you're a global company, obviously, if you're a global enterprise, you need to have a nice global infrastructure. You have to have a great computing infrastructure no matter what. In fact, I probably should just take out the word computing in here and just say infrastructure. And of course, in this day and age, we we've always had system security as part of this, but we've broken that out lately because it is such an important part of this, important aspect to not only secure your data and your systems, but to secure your company. That's a big thing. So that tends to be the layers. And excuse me, I have to take a drink of water here. I got a little tickle in my throat. So again, this is not. It's not like everybody in the world is in the same state with enterprise architecture, and it's not like enterprise architecture is a common approach when companies do it. It's evolved, and again, it started out as an IT thing. It's become less and less of an IT thing, especially in the last 3 or 4 years. In fact, Gartner puts together this thing that they call their hype cycle. I don't know if you've ever seen it. It's an interesting thing by itself. But what they recognize is that when technology comes out, there's usually something that triggers it. And then there's a lot of hype built up with it sometimes, where you get to this peak of what they call inflated expectations that this thing's going to do everything for you. Okay. And then people start realizing after they've made some expenditures that, no, it's really not. And you get into this thing that they call the trough of disillusionment. Some things will die there. Okay, in other words, they didn't pan out. We're going to go on, but typically something will come out of that. It may be a segment of the thing that you started out doing, or it could be the whole thing. And if it has enough momentum, you'll climb the slope of enlightenment until it finally gets to a point where you get a plateau of productivity. This is the hype cycle that I put together for enterprise architecture. It came out of IT as an IT framework, basically, and right now that's well established. Most IT groups, big IT groups, do enterprise architecture. But what we've seen happening lately in recent years is trying to move it out of just being an IT thing. Now, one of the things that happened is we saw EA popping up as a separate I should say a separated function in different organizations. In other words, IT had theirs, operations had theirs, research and development had theirs, and it didn't work out very well. That blended EA that we called it, where we tried to at least communicate with each other, just wasn't working out really well. What's emerged is working out. That's been working out really well. And in fact, I would say it's already hit this peak and going down this slope really fast, so much that it's going shoot just right back up. Is this idea of hierarchical EA governance? The idea that you'll have a single core EA group that sits at a high level in your enterprise. It could be reporting directly to the CIO or to the chief technology officer, and then each of the organizations will have their segment because obviously they have their specializations, and you want to bring those subject matter experts together. At Spirit, we have a technical fellows program. Most of the guys that I consider to be our enterprise architects, even if they don't have that title, come from the technical fellows program. They tend to be our subject matter experts in all the critical areas of the company. So they come together at least as our technical side of EA to do that. We also have EA organizations that are more uh, prone to the business side of it, and even a lot of those are hybrids between the people who are doing technology and the people who are focused on business. But I always say that that's one of the things about enterprise architecture. It is the discipline that connects technology to business. And so, going back to what I said earlier, that enterprising isn't just about a company, it's about opportunities too. Most of our opportunity comes through disruption. The fact that technology is going to make a change, or we need to change technology in order to address a business disruption that we might have. The people that do that for us are our enterprise architects. They're responsible for performing the analysis of the business structure and its processes, and are often called upon to draw conclusions from information collected to address the impact of the enterprise architecture. And the things, especially that we get our hands around, is how effective are we? How efficient are we? How agile are we? How durable are the things that we do and the products that we produce? And how do we embrace innovation? How do we get ready for it? How do we drive it? How do we do it ourselves even? If you look under that, and I broke that out into what I consider the major categories of enterprise architecture: process, technology, information, application. You look at the words underneath there, they ought to be very familiar to most of you. Okay? They are the things that we tend to do. Now, it's interesting. I always say that 20 years ago, these things were considered fringe for industrial and systems engineering. Now they are mainstream, all of them. We do all these things. operations. Okay, we've always had operations research in there, but operations research morphing into this bigger thing that they call data sciences. You know, most of us actually, that is one of my titles is data scientist. I'm the technical fellow for data sciences at Spirit. Um, it's it's recognized now that industrial and systems engineers tend to be the data scientists, and we're doing more AI work. We're doing more what I would call modeling and road mapping work. We're doing more of the content management where we're trying to actually form our knowledge base for the company. And of course, we've always been involved with things with humans factors and all that. So one of the goals of EA is to manage change and optimize business outcomes. You know what? That's been the goal of most engineering organizations forever. That has been the goal of most systems engineering organizations forever. Production engineering organizations forever. Okay. So is enterprise architecture anything new? Probably not. It's probably like a lot of things we've always done, but it is a coming together of different disciplines to do this finally. It is a very interdisciplinary approach. And right now it's being driven by what I think are five key areas for improvement. One is everything that sits around big data, the fact that we need to federate our enterprise data. Second is building these digital threads for our company. In fact, I kind of call it building the digital fabric. It's taking all these threads and making them work together. And that's the collaboration and workflow that needs to happen in our companies. Enterprise intelligence, the analytic driven performance that we seek in our companies, or I should say in our enterprises. It's hard to divorce that enterprise and company thing. I do it all the time. I tend to want to always say that, but it is a bigger thing. Enterprises aren't just our companies, it's our vendors that we deal with, our customers, the regulatory agencies that affect us. That's all part of our enterprise and us being enterprising. And then the lean enterprise itself, how can we create agility in our in what we do? And then how do we handle this thing that we tend to call disruptive innovation and not look at that as being a negative thing for us, but actually a very positive thing for us, that there's opportunities when there's disruption. And basically, how do we stay technically ready for those disruptions? Now, again, I've got a slide, and I know I'm running out of time, so I don't want to spend a lot of time on any of these, but there's some key points on each of these, and this presentation will be made available after this too, by the way. In big data, people tend to think of big data as being an informational technology thing to do. No, it's an informational technology and it's an operational technology thing to do. While IT groups are very concerned about building the data lake and making data available in a way that it can be visualized in a very intelligent manner, we have to consume that data. The operational groups have to consume that data. The rest of the enterprise has to consume that data. Are we ready to do that? Do we have the systems in place that can get to that data, even if that data was really great? It was perfect, and we had ways to access and all that. Do we have the tools and the talent in order to do it? Have we adopted the data science practices to do it? Have we built a way to make some of that automated and be used in real time for things like controlling equipment in our shop and having that adapt in real time if it's needed? Okay, you can see sitting around this block of stuff that I put under the big data DevOps umbrella is all these things. And if you look at it, a lot of these are the words we hear from vendors all the time, that you really need to be doing these things. They're right, but there's rhyme and reason to do it. And you don't want to just piecemeal it together. There's rhyme and reason to do this. And the way to do this is to have a really sound enterprise architecture to begin with. The digital threads, again, there's many of them. Guess what? They all tend to work alike. They're all about life cycle approaches to making things ready in an electronic manner, so that things have every electron basically has a life cycle to it, if you will. And some of those things will manifest themselves in reports, and some of them will manifest them in streaming of information that's used to control things, and some of them will manifest themselves in artifacts or websites or something like that portray how well your company is doing. And some of them will be the things that you actually measure how well your company is doing by. Things like your as-built thread, which I should say your as built thread of traceability that you have in your company, or your as maintained, or your as serviced, or whatever other as is type activity you need to be able to trace back into your enterprise's life cycles of activity. This is a whole seminar by itself. I'm not going to get into this great detail, but basically, again, we are at an interesting crossroads where we have a lot of people who have not really been trained to do things like analytics or suddenly be asked to do it, and are relying heavily on the tools, and without really understanding necessarily how the tools are doing things for them. I'm teaching this neural net class right now. Most of what my students do, they don't really even need to understand neural nets in order to be able to go out and use the software to do a study. And they would do an adequate job on it. And for some companies, that might be good enough for the majority of their workforce. But if you really want to be able to work up here at these higher levels of capability maturity, where you're being innovative and you're being agile, it's going to take people with a lot of skills to do this, and skills that typically come from people who've had OR or ergonomics or other analytic based training in our areas. Then there's the lean enterprise. This is a diagram I got from Scaled Agility Services. They have this new lean uh, enterprise architecture concept that they've put in place that a lot of companies are starting to adopt. My company's looking at it really close. But if you just look at some of the things that are on here: Scrum Master, Product Owner, Production Management, Enterprise Architect. Those are things that we Kanban. Those are things that we as industrial engineers have been well trained to do. As industrial systems engineers, I should say, that we've been well trained to do. And then disruptive innovation. How we do things like create an outcome model for our company, do a technology forecast, build a capability model, and then build a system roadmap. That is all part of embracing disruptive innovation. Bringing agile practices together with breakthrough technologies and understanding what the impact of disruption could be to our companies. Again, something that we are very good at doing. It's pretty much the nature of what we are. So some of the trending things that are happening right now is a lot of emphasis on digital twins. A lot of companies throwing a lot of money at trying to virtualize their environments so that they can do a lot more deeper analysis, which requires people who really understand how to do complex modeling, like we do. Execution, being able to take that planning information and turn it into something that's actionable. That means people have to be smart not only about all the business processes that fed into that activity, but the activity itself. And again, we tend to be those kind of connectors. Machine learning, rapidly predicting outcomes and prescribing actions. Okay, again, that is part of the predictive and prescriptive analytics that we tend to do. And of course, a lot of the newer type of AI activity that's going on will lend itself to that too. And then industrial IoT, automation. That's what it comes down to. What is the automation of the future going to be like? Okay, it's not going to be just about taking disparate sensor boards and migrating them at a point somewhere in a lab somewhere at a distance. There will need to be control right there at the edge itself. In other words, we'll have to have smart machines, and that smarts is going to have to come from somebody. And I think that will be mainly from us, either translating heuristics that we have learned over the years or mining data and other information to determine what we really need to be doing as far as control goes. There's a lot of things that that enterprise architects produce. I'm just going to throw this up here. I'm not going to go through any of them in great detail. Uh, Not the least of which is models, models, models. And again, we're one of the best at doing modeling. So I'm going to wrap it up here. Some of the key takeaways I hope you got out of this is that EA, at least in John Huffman's opinion, is a special case of industrial systems engineering. It's a new opportunity for us, and it's an opportunity for a lot of the students that are out there as you start putting your programs together. You may have noticed that a lot of those things I talked about aren't taught typically in an undergraduate setting. Some of them are, not all of them. All right. it's one of those things that it's almost required us now to go on and get graduate degrees and really and specialize a little bit in some of these areas. Um, I know for me, it was a real help taking OR classes over the years. I think that really helped me get started in a lot of this, and it kind of fed into AI. And because I was good at those two things, I got good at systems engineering, and having 30 something years at my company, it really postured me well to become an enterprise architect. EA is evolving. It's not just an IT endeavor anymore. It's becoming an enterprise scale strategic technology and process change management function. And that is critical to say it is change management. It is about making things different as we go along. Uh, Digital transformation efforts are accelerating. I don't think that's news to anybody, but it is causing us to realize that we don't have enough resources to do it. So we're starting to take a step back and say, we have to adopt more agile processes, lean things out a bit more, and then really leverage operational technology more than we have been in the past. And then the last one here is ISEs have the tools, the talents, the skills, and demand for the next generation of EAs. I don't want to whet your appetites too much, but a lot of you, I'm sure, look at what ISEs tend to earn in the industry, and you'll always see data scientists at the top of that list. What you rarely see on that list are enterprise architects, and the reason for that is it is kind of rare for somebody to become an enterprise architect early in their career. They usually have to have many years of exposure to the business in order to be good at connecting technology to the business. But I can tell you right now, if they were on that list, they would make everybody else look like they were getting. They, they would make everything else look very small. Let's put it that way. Enterprise architects tend to be some of the most valued people in the organization. And again, I should mention this too for the students. Communication is a big part of being successful at this. You have to be able to talk to almost any level of individual you're going to deal with, whether it's a mechanic on the shop floor or the CEO of the company. You're going to have to be able to give things to them in a way that makes sense for them. So I'm going to stop it there, and let's see, we still have 7 minutes, so I did okay. I'm going to open it up for any questions that you guys might have. Come on, you can't tell me I was that thorough or that boring.
It was very thorough. For successfully fitting all of this in less than an hour. That's very impressive. Um, I have a question. Yeah, I mean, it's not really a question as much as a statement, and I'd like to hear your thoughts on it.
Yeah,
Um, a lot of this is internal, right? We're internal to the business, right?
right,
A business a design, really,
right,
and how we operate internally. But it does also have quite a bit to do with the external customer, right?
exactly.
Um, and of course, it has to be repeatable and robust, right? For an external, all the external factors
Right,
that this business.
right,
And I think it's interesting. We're seeing lots of newer companies, newer businesses that are popping up that I think have done this very well.
hmm
Um,
right,
uh, Places like Tesla, where they're using data um, just incredibly well, right?
right.
And but there are also concerns that come with that, right? They want
Yes.
all of our data, right? They want their cars to talk to them and tell them what's wrong
hmm
with them. You know, I saw a meme the other day that said that Tesla's playing with having their cars order themselves parts, right? And they said, how scary would it be to look at your bank account and realize that your Tesla ordered itself new wheels,
Yeah.
uh,
Right.
and I think that's the way of the future, and that's just a totally different uh, consumer culture also that we're moving towards.
Yes.
So, what do you think about that? I know that it's kind of a separate, but also the same thing that we're talking about here.
Right. No, no, that's a great question. And in fact, kind of tickled a couple neurons of things I should have mentioned as I went through that. Uh, I did say that we have to think in broader terms when we think about enterprise. Yeah, I would say that the majority of the activity that goes on, it tends to be toward internal processes and your data, your personal data, and all that. But obviously, there's a lot of connectivity to the outside world. The streaming of information, what I would call the competitive intelligence that we need to have, and that our customers and our suppliers and our regulatory agencies and all that are all part of that enterprise idea. Let me just, my phone is telling me that it's time to get off. Um, um, I Emmett, I think first off, look on Tesla and some of the other newer companies, they're they're actually it's a lot. I don't want to say it's easier to do this, but it's when you have greenfield, it's a lot easier to bring in new technologies and make that connection, and understand what kind of data you need and build that data lake. One of the issues we have at Spirit is I call it the layers of the onion. That we keep putting layers of the onion every time we go through a new phase of development, if you will, to the point where it's very difficult to get back to that core and impact that core. We either are trying to constantly try to pull layers off the onion, or we just keep putting more and more layers on it, where it's really hard to go back and say, what is truly our enterprise architecture here? I mean, it could really differ from airplane program to airplane program at Spirit, because we are an older company. Relatively older company, in that we were Boeing at one time, and we inherited all the practices we brought over from Boeing, for 75 years. Some of this, it's a lot easier if you just start from scratch. I hate to say it, and really involve your suppliers, really involve your customers in the design of your product and in the design of how you're going to do your business practices and all that. I think a really critical one of the deliverables I had on there was the outcome model. That I think this is the key artifact that enterprise architects have to take care of. They have to be considering what outcomes are we driving to, and that's going to be driven by the voice of the customer, obviously. All right. What kind of airplane does Boeing build next? What kind of airplane program does Spirit go in bid for? All those things. What kind of military programs do we get involved in? All that. It's going to have to be based on some kind of perceivable outcome, both an outcome that affects industry, an outcome that affects the consumer base, an outcome that affects us. All right, so we have to do that. One of the techniques I'm a big advocate of for doing that is quality function deployment. Using these things to say, what truly is driving us. What are those things we want to deliver? What are those things that we want to service? Versus what are we capable of doing? Where do we need to shore up the gaps? Where do we need to leverage technology better? Where maybe do we need to develop technology? If we do that right, it gives us some ability to say this is where we need to point our research and development in the company. We right now, most of the research and development that Spirit does is applied research and development. And I keep saying, there's basic research that needs to be done here, but it's hard for us to even figure out what kind of basic research to do because we don't necessarily understand how basic research helps us get to certain outcomes that we need to do. Again, I think that's one of the things enterprise architects do is they make that connection between those things. Did that answer your question or confirm your statement?
Absolutely, absolutely.
Good.
Thank you so much.
You're welcome. Anybody else have anything before we let go here? I know we're on the hour, so um, I just want to thank you guys for letting me do this. Again, it's one of my crusades in life is to get the word out about this. I hope it becomes a topic that gets a lot more exposure through IISE, in COSI, and in forums and some of the other societies that are involved in doing this. I'd like to see us all come together on it, I hope. I think it's an umbrella that can help us even in, we can think of our chapters as enterprises, and we might be able to leverage some of these ideas to make our chapters stronger going forward. So, again, I thank you. this was the first one of these that we've done. We hopefully will have a lot more to come. Again, I have even in here you saw that there were a lot of different topics that could go into greater detail. If you ever want me to come back and do another one on, say, on enterprise intelligence or on enterprise analytics, I'd be more than willing to do that, or any other topic. But we really like to invite all you guys. If you have something you'd like to present to the chapters, please let us know and we'll get that going. So, Emmett, any last words from you?
Absolutely. I want to thank you, John, for doing this first presentation here virtually. I think it's an awesome offering, and of course the topic is fantastic. And like you said, it's accelerating. Um, we're adopting EA faster than ever, and that's the way of the future. And ISEs are more involved and more involved than ever as well. We're going to remain in demand, and I think that's great for the profession. And I'm sending you a innovation from all of us. So thank you so much
Thank you.
for having this presentation ready.
Uh, Thank you, Emmett.
All of our we were up to 24, I think, at one point. Fantastic reach.
Good.